Hi, so I'm Helen Bravo from Checkmarks, and I'm very happy to be here talking about DevOps, and not actually just talking about DevOps, but rather talking as part of the whole separate track of DevSecOps, which is a huge progress. Since I have been doing the DevOps talks for about 4 years, I think that was the first time when I had this talk in OWASP Snowfrog, I think, in US. And what was it back then? It was DevOps is here, and there are companies like Netflix and LinkedIn who are doing this cool thing, deploying a few times a day, and that's called DevOps. And we all envy them, but probably no one actually do that except them. Since then, 4 years passed by, and things changed. Things change also from technology perspective, and things change from process perspective. So much more companies, much more projects are doing DevOps now. But the thing is that the definition of DevOps is actually quite wide. So we have this whole huge track here. A lot of people are talking about DevOps, and it's a very different definition for each and every one of what they mean for DevOps. So I wanted to map that, and I also wanted to map in my presentation what DevOps, what processes, what are the building blocks of DevOps, and how security and security checks might fit into each and every one of them. So looking as a general approach, DevOps is about processes, connections between development, tests, and delivery processes, and automation and tools. And that's probably the key here, the automation of those processes. So if we take a look into the building blocks, we have, and let's go backward, let's do some reverse engineering. I have been thinking the whole way going backwards, and you will see that down the presentation. Production. Production is not an actual part of DevOps, but rather a finish line. So we are going there, we are striving to get there, but the process itself is getting there. So the steps we are interested in are CI, CD, and development. Those are the building blocks where the processes actually happen toward production. And there might be several security checks that might be we can apply on each and every step. Well, in production, we have some security checks that we can put there, like WAF and RASP. And there are, for CI and CD, solutions like IS-Dust, even penetration testing. We will discuss in which cases it might fit and in which not. SAST also can be a solution for certain steps. So the question is, what actually each and every building block is about. Development is pretty simple one. We have the flow of checking out the code. The developers sit around in their desk tops, and they check out the code. They do the development either on IDEs or without IDEs, depends on the language they use, then compile and commit it back. And that's a significant part of the process, that's where it begins. And some security checks can be applied here, again, dependent on the whole process. So let's not dive into it now, but rather further down the presentation when we see the whole process composed. Next step is blocks of CI and CD. So, and that's an area of a lot of confusion. What CI stands for, what CD stands for. And if you ask people, a lot of people will say different things. Sometimes they confuse CI with CD, and in CD, there is also a separate confusion about it. So CI is basically only the build process. It's taking the code checked in and committed, or committed by the developer, adding it to the main line, and making sure it doesn't break the main line, it doesn't break the code. So basically, it's about tools. Using the right tool, and there are great tools for that today, building a pretty simple process will make that for you. And it's also a great place to apply some security checks. Next step is a bit trickier. What CD stands for? It's also continuous something, but what D stands for? And that's an important part here, because in general, the process is about taking the code, taking the change from developers up to the user. And taking it to the user might mean a lot of different things. It might be a SaaS application which is installed on cloud. It might be an on-premise application installed and delivered for each and every of your customers. And it's a very different process of deployment. So that's CD. But there is a huge difference between continuous delivery and continuous deployment. And in a lot of cases, we say CD when we meet one of them without making clear what exactly. And when continuous delivery, basically both of them go from committing the code, running the unit test, building the package, and running the acceptance test, which might mean a lot. Automatic testing, a huge suite of automated tests. But then the difference is about how we switch to production. For continuous delivery, we do it manually. And for continuous deployment, it's done automatically. And that's a difference. And that's, this difference makes also a huge difference for security. Because basically when it's automatic, you don't have a chance to stop it. It runs, and either you inherit in the process some checkers and fail the process upon those checkers, rather on manual stage, you have a point to make this decision. Okay, you can see, okay, we have certain results of these tests. We have certain results of security tests, and we might decide either to go or to stop it, to make the show stop. And that's a very important decision the security policy should define. What are the showstoppers? What would you stop the production, the delivery for? And it doesn't matter the delivery is automatic or the delivery is manual, but you should ask yourself this question first, and only after that you should think how you will implement this decision. So we have heard a lot of talks today, and some of them were asking how many of you are in the waterfall and how many of you are in continuous deployment. And some guys were telling us about the great process they have over continuous operations. But the truth is that most projects are somewhere in the middle. And it's not even organization-wise. It's rather specifically project-wise, because there are a lot of organizations where you can find all of them. Some legacy projects are still releasing each 18 months. And some newer projects are deploying a few times a day. And for those projects, you shall find a different implementation of security policy. And that's a very important decision, because otherwise it will probably, I don't want to say it will not work, but they will reject it. You will be fighting. And there is a way to find a way, to find how the security might fit each and every stage where the project is, each and every flow the project is implementing. The important key sentence here is the further right the project is on the DevOps scale, the further left the security should start. And why is that? Let's take a deeper look into how the process goes. If we look into CI/CD, again, we have dropped the deployment process. Deployment process is less important for, in our case. If we look into this flow, in this flow, we have the CI and the CD components. And it doesn't really matter here whether the CD is continuous delivery or continuous deployment. So what happens here? We have the checkout and the compilation and the unit testing. That's continuous integration. Continuous integration is the first step where you can start implementing the security policy. Then we switch to the CD part. In the CD part, there is the package creation, the deployment, and the whole set of environments that you might choose to deploy, and the end-to-end tests. So again, going backwards, we can take a look into the end-to-end tests. End-to-end tests differ very much for those who go for continuous deployment versus continuous delivery. For example, if you are not practicing continuous deployment, you can really afford doing the penetration testing. Penetration testing depends on the deployment environment. You choose to put there several environments, not just staging and testing environment, but just deploy a separate. And I know a few of our customers who work this way. If, for example, you're releasing on-prem application, which is released each 2 months, each 3 months, you can really afford putting aside a separate system and run penetration testing on each version. It's really possible, and you will still doing the CD. It will not stop the CD, it will run aside of it. The same goes for Dust and IaaS. Dust and IaaS are both a bit time-consuming products. But again, then they can run if they are not stopping the process. And here, at the end of the process, it's really the final frontier before either taking the decision to go to production or going back into the development process. So if the development process is not stopping and the production is not stopping, they can keep running aside of the whole circle. And here again, we are coming back to the question, what would you stop the process over? If penetration testing finds, what type of finding would make you say it's a showstopper? We are not proceeding further. Or if the Dust finds, or if the IaaS finds. And here is another very important question, how do you trust? How do you trust? Well, penetration testers usually, it's a pretty trustable source, but the tools, we all know the tools might be different. There might be more trustable and then might be less trustable. And that stability and the trust is very important for the decision making and for choosing the place in the process where you choose to integrate the tools. Another important aspect of the decision making is a dependency check. And that's something that you can also do in several stages of your process. You can do the dependency check when you create the Docker image. And it might be an important choice to do it there because actually Docker brings a difference here versus the packages we used to do 2 years ago. Because usually you don't, even if you did the dependency check in previous steps, you did the dependency checks of the libraries that you are using in your code. But into the Docker, you are also packaging things like OS or web servers, which were not checked as part of the development process. So this is a point where you should take this decision, and you might want to do the checkers both here and in previous stages. And here we also have the continuous integration part, where we can do also a lot of checks. The continuous integration part is very important, actually, because it happens usually much often than the continuous deployment. Well, for those who are doing the continuous deployment, it's actually the same pace. But for those who don't, and that's, let's admit, the majority of the project, it actually happens much often. Usually, the continuous integration is few times a day. And the CD process might be once a day, a nightly build. It might be also once a week for a certain project. It depends a lot if the project is legacy or new. And that's actually also very important input into your decision. Legacy project brings in a lot of old code. old code that nobody actually knows what the hell happening there. It's millions, in a lot of cases, millions of lines of code with a lot of security vulnerabilities that have been there for years already. And that's an important, and here it brings us to an important decision how we treat this fact. Do we want to fix everything we find, or we want to do some segregation? And how this out, we will do is, I would like to map this into some sort of policy mapping and policy implementation mapping into the process. So going further, and from the CI decision. The CI decision is mainly, do you break the build over security? And I have been in a lot of conferences when the keyword would be break the build over security. Go ahead, guys, break the build over security. It's a great goal to go for, but the actual thing that DevOps people will probably hate you. Not, I don't know if you personally, they will probably hate all over the world, because the thing they hate the most is when the build is broken. But the thing is that broken build could be justified. And that's the key here. Can you bring in the tools that broke build over very justified results? If results are not justified, they will eventually push you off. They will eventually block the option of breaking the build, because they don't want to go around and fix something which is actually false. So the CI is something that all the system is dependent on. CI basically delays all the process significantly, much more than CD does, because that's when in our own company we have in the group I work with, we have 40 developers. When the build breaks, all 40 developers are unemployed. They're sitting and waiting till the build is fixed. So if you have in a big organization 365 developers, and each developer breaks the build once a year, each day the build is broken and they're not actually proceeding, and the process is stopped. So breaking the build is a very, very significant decision. And security professionals should bring the requirement to break a build only when they are really, really trusting the tools over which results they want to break the build. It shall be very, very qualified results. So what are the problems of security tools? Security checkers, security checks with the process. The speed. It takes time to run. It takes time for the security analysis tools to run. And the stability. The stability is basically the quality those tools bring, and it's some combination, sort of combination of time it takes and the quality it brings. So if the security test runs for 7 hours, 14 hours, and afterwards brings you 300 results, out of which 200 are false positives, you can't really break the build over it. And you actually have a general problem dealing with it as a general approach. So here comes the thing of the policy definition. The policy shall fit the process. The process shall not dictate the policy. After all, you are the security professionals and you shall require what the security stage should be. But the thing is that getting to the security stage is a process. You shall not start from that point, but you rather shall get there gradually. Like one of the possible approaches would be dividing, especially it works for legacy projects, dividing to backlog and new findings. If you have 1 million line of code or 3 million line of code, and you scan and with SAS tool, for example, and you probably that size of a project will bring you hundreds of findings. So the project has been developed already for 10 years, 5 years, and most of developers that started developing it already left. Nobody knows what's going on there and how to fix it today. On the other hand, they keep developing it. So the new findings are much easier to be fixed. So if you would be realistic, do this division. Let the past be treated separately and let the future and the today be treated in a separate way. So you can implement the policy, you can drop the build over new findings, while the old findings, the findings of the legacy code, you can put in a backlog and require, as a security team, require some sort of burn down for this backlog over the versions and as a process, as the project goes further. That will actually make much more sense than failing the build over all results. Because until they clean all hundreds of results, it will take probably years, or if they work very fast, months. Another approach might be evolving policy. Start small and add more and more checks as you go. So start from the most important checkers and then expand it. Again, even for that approach, you can take both the division to backlog and the new ones, and the most important versus the less important. Another option is segregation of the policy over the vulnerability type or age. So you might want to be aware of everything that happens, but you would require, as a showstopper, only certain things. Like it might be very high severity vulnerabilities, or it might be an age. Age, it's also a very valid approach, which says, and it's based on some standards. Some standards require that sort of appliance. When you have a vulnerability in your code for more than 30, 60, or 90 days, it gets a higher priority. So if it's only for 30 days, guys, you have some time still to fix it. But if we have 60, I will fail the build. And that's something that you can get out of tools. Tools allow this option and this information with regards to the findings. Another important aspect to be taken care of is open source. Open source, it's relatively, open source security is surprisingly relatively new part of the whole process. And it's actually surprising because open source has been here for years, more like, I don't know, 20 years now, more. But the security of open source still is not part of the policy for a lot of organizations. Like okay, we started thinking about it because the legal department asked us, but the vulnerability open source brings is totally comparable to the vulnerabilities you have in your internal code. It should be minded the same way, even maybe more serious way, because the vulnerability you have in your code, you are aware of, or maybe someone who is going after you aware of. The vulnerability of the open source are out public. Everyone knows about them, and if someone wants to use it, they can use them first, and only after that try to discover the vulnerabilities you have on your code. So we have the code produced in-house, and we have the open source. And the question is, where exactly would be the best stage of the process to implement security? I will be probably saying something very known here, but the earlier you fix the issue, the cheaper and easier it would be. So let's go and take a look into the development process. So in the CI process, you have your options. Now, let's see what actually happens if you shift it all to the developer's plate. Let's not implement it in the CI, but let's require the developers not to commit to master branch if there are security vulnerabilities. That is something that will actually eliminate the requirement to fail the build, to do the whole headache for the whole company, for the whole project, but it will shift the headache to be personal developer problem. So at the beginning, when we do the designs, it's a known thing. Other people talked about it today. Designing for security is important. It's not part of my presentation here. But the thing is that the SAST part is something that can be done for developer at the development stage. And also, this information is pretty known. You probably have seen it before. You can use it with your management. It's very, management usually love the slide because there are numbers here, and you actually can show them and see it's cheaper there. Let's do it cheaper. So the slide is used for years already, and it's still true. You can't really measure the exact number, but in general, it's right. So taking a look into the development process. We have the checkout and we have the IDE part and the compilation and testing. So here, we can actually do a lot to prevent the security problem from the start. When the developer is writing the code, there are tools which are integrating with the IDE and allowing to do the security scan from the IDE. Also, the open source analysis shall be tested at this stage, because in most cases, the one that chooses to use certain library or not to use it, first of all, is a developer. Open source libraries are not going through certain committee. Well, there are companies working this way, but there are few of them. In most cases, developer goes to GitHub, looks whatever component actually does what he needs, downloads it, and puts it into the POM file he's working with. So already at this stage, the open source analysis might be performed. And that is actually, especially for open source, it's a very important decision. Because if open source has vulnerabilities and you are not a contributor for this open source, you will not start fixing it. What you will do, and what you should do, you should change the library. And in easier case, it might be a look for a newer version, and the newer version already have it solved. But in some cases, there is no newer version, so you should change the library entirely. And that's a big decision. And as early as this decision is made, the less painful it would be to do the change. So this part is actually the leftist frontier, the most left frontier for security checks, and the less expensive and the less painful for the process. So taking it back to the whole picture. So we have the CD, the CI, and the development. And you can choose to implement security wherever it works for the project. And for some project, you will require, it might be enough just to do the checks at the end of the whole process. Even if they do CI/CD, but they release once half a year, they do it in circles, but they have enough time to do penetration testing. And you don't have the tools and you don't have the time, and the project is legacy. So it's a huge headache now to start scanning it with source code analysis tools. Do only the checks at the end, and that would be good enough. On the other hand, if you have continuous deployment, you can't really afford it. Or if you don't have continuous deployment, but you have a very high-paced deployment, which is also something that requires you to shift left, to take the checks and do it earlier, to do it as part of CI, to do it as automatic parts of the CD. But even then, the decision of how to work with it should be made according to the project. What is the size of a project, how old it is, and how responsive the developers are. There is something that I didn't mention because it's really known thing. You will eventually have to work with the developers. Developers will have to fix the findings. So there is a need to engage the developers. But the thing is that engaging the developers, it's besides the stuff that that other lecturers said today and yesterday. It's basically the same key. It should be a quality result which actually not false positive, and it should be fast. Because if security delays them, or if security brings not very qualified findings, they will lose their trust. And if you do bring a serious results, they will eventually do that and will embrace it into the project, into the process. So the main takeouts that I would say for me would be security policy that fits the flow. Shift left is important as the further right you are in DevOps, and the open source security shall not be neglected because it's a very significant part, the same way as your own internally produced code is. That would be my part, and if you have some questions, I think we have got more time.
Some questions?
It's over there.
So you mentioned that it is always better to fix in the early stage during the development phase. But what if there is 10,000 issues, and how do you need to prioritize it? Maybe developers are working, it's not feasible to fix all those issues.
That's right, yeah.
And they will start to hate because it's finding all these things and they don't have enough time to fix it. So how to address this problem?
Yeah, I have mentioned it earlier. Basically, if you have 10,000 findings, the best way would be to divide it, to say, okay, we are starting our program now. Let's put the 10,000 findings aside and make a plan of eliminating it. First the highest, then lower, and let's treat only the new findings. The one that are created on the code produced right now. That would be the way that will buy your developers, because it will be close to the time they produce the code. They will understand where it comes from, and they will not have to dig deep into millions of lines of code produced years before them. That will make the whole process easier. It will not probably reach the security you would strive for, eliminating all at once, but it will make it happen. It will make it proceed to go further. That's something reachable, like a low-hanging fruit. Thank you very much, guys.
Thank you, Helen.